Here's the answers for 10.4 day 1. Pause the video if you need to look at these longer. And here are the graphs for 10.4 part 1. Again, pause the video if you need to look at these longer. Today we're going to be looking at writing equations for parabolas in standard form, which again, we talked last time. Our book considers standard form to be what the rest of the world calls vertex form. So we're going to want to write an equation for a parabola in vertex form, and that is this format. HK is the vertex, and A is going to be some number that we're going to figure out using one of these points. So your first step is going to be to take this vertex, 1, 2, and put that vertex into this formula. So we have y equals A times x minus, the x value of our vertex is 1, squared, plus the y value of our vertex is 2. Now, if our x value had been negative, then that would have been minus a negative, so it would have turned into a plus. If our y value had been negative, it'd be plus a negative, so it would be minus. Your next step is to take one of these points, and you can choose 0, 0, or 2, 0. I'm going to choose 0, 0 because I think it looks easier. You're going to put 0 in place of x and 0 in place of y. So this y is going to become 0. The x is going to also become 0. And I'm leaving these colors in because I want you to see where all of these things come from. So the 1 and the 2 came from the vertex. The x and the y come from a point. And now we're just going to do the math, and the only variable that we don't know is a. So now we can figure out what a is. So we've got 0 equals a times 0 minus 1 is negative 1. Negative 1 squared is positive 1. And then plus 2. Now that's 1a plus 2. So we would subtract 2 on both sides, and then divide by both sides by 1. So we would have a equals negative 2. Now, the point of this is not to figure out what a is. That's not like the whole goal. We need to go back to this step. Go back to the step where you put in the vertex. And now we know what a is. So now we will write in y equals negative 2 times x minus 1 squared plus 2. And that is your final answer. So use this formula, plug in your vertex, plug in a point. So in this first step, you're plugging in your vertex. In the second step, you're plugging in your point. And then your third step is to solve and figure out what that a value is. And then your fourth step is to go back to your first step and replace a with that number that you figured out. Okay, let's try that again. Write the standard form. Again, we're going to really be writing the vertex form of the quadratic function that satisfies the conditions. So they give us our vertex, which is our h and our k, and they give us our point, which is going to be x and y. Now, some people like to put all of these in all at the same time. I think that that gets really messy. I like to show every step just so that I don't get confused. So I'm starting with this formula. My first step is to put my h in. So I'm going to have y equals a times x minus 2 squared plus 3. My next step is to put my x and y in. So y is 4. X is 0. And my K is 3. Okay, so step 1, you're plugging in your vertex. Step 2, you're plugging in the point. Step 3, we're going to figure out what A is. So I've got 4 equals A times -2 squared. -2 squared is 4. I'll subtract 3 on both sides and then divide by 4 to figure out that A is 1/4. Your fourth step is to go back to your first step and now replace A with what you know A is going to be. So I'm going to label that with my fourth step. My fourth step is to rewrite this as Y equals 1/4 times X minus 2 squared plus 3. You have to plug things in and figure out what A is, but the purpose of the problem is not simply to find A. The purpose is to write an equation for the function, so you have to go back to that first step and plug that A value in. The height y in feet of a ball thrown by a child is given by y equals -1/12 x squared plus 2x plus 4, where x is the horizontal distance in feet from where the ball is thrown. Now I'm going to draw a quick little picture over here. So this kid is going to throw this ball and it's going to follow the path of a parabola. How high is the ball when it leaves the child's hand? That would be this point right here. So I'm going to label that part A. How high is the ball at its maximum height? That's going to be part B. How far from the child does the ball strike the ground? That's going to be part C. So we need to know something about each part of this. Now, the other thing that you need to know is that when you're looking at this equation, y is like the ending height. And the really cool thing about what everyone in the math world calls standard form, this is truly standard form. This last part is your y-intercept. So you may want to label this y-intercept. And this is the nice thing, because the y-intercept is this point right here. So we now know that the y-intercept for this graph is 4. So how high is the ball when it leaves the child's hand? It is 4 feet high. That's our first answer. How high is the ball at its maximum height? Now, this point B is going to have 2 pieces of that coordinate. The first number is how far out we are, and the second number is how high we are. So really, we want the y value of the vertex. So for part B, you are really trying to find the y value of the vertex. So let's remember how we did that. For part B, we need to start by doing x equals the opposite of b over 2a. That will give us the x value of the vertex. Then we plug that in to get the y value of the vertex. So opposite of our b value is -2 over 2 times our a value. And if you plug that into a calculator, I would type it in like this. So -2 divided by parentheses 2 times -1 over 12. I get +12. And that seems weird, but just trust it. That's +12. That means the x value of the vertex is +12. We need to plug that number into this equation to figure out the y value of the vertex. So again, grab your calculator. -1/12 times parentheses 12 squared plus 2 times 12 plus 4. I get 16. So we plugged in 12 and we got 16 as our answer. That means 12 feet in, the ball is 16 feet high. So how high is the ball at its maximum height? 16 feet. How far from the child does the ball strike the ground? That's at this point. This point is going to be something, comma, 0. So that's when y is going to equal 0. We have to figure out the x. So for part C, we are looking at, let's use a different color. 0 equals negative 1/12 x squared plus 2x plus 4. That means we need to use the quadratic formula. So you might have to look back at your notes to find the equation for the quadratic formula. We need to do x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Pull up my calculator. 2 squared minus 4 times negative 1/12 times 4. 5.3 repeated is underneath the radical. What did I say it was? 5.3 repeated. And 2 times negative 1/12 is negative 0.16 repeated. 166. Okay, so to figure this out, I would do, oops, didn't want that. Negative 2 plus the square root of 5.3 repeated equals divided by negative 0.167, negative 1.85, negative 1.86. That would be negative 1.86 feet. That doesn't make sense. So let's try the other way using minus. Negative 2 minus the square root of 5.3 repeated divided by negative 0.16 repeated. 25.9, so about 26 feet. So the answer to this is about or almost 26 feet. Okay, so this problem is huge. There's a lot of pieces to it, but they're trying to point you toward the beginning of the parabola, the middle of the parabola, and the end of the parabola. The beginning, how high is the ball when it leaves the child's hand? That is simply your y-intercept. How high is the ball? That's the y value of the vertex. And then how far? Put 0 in here for this ending height. Use the quadratic formula to find the x value where the y value is 0. Okay, here's your assignment for 10.4, day 2, part 2.